Hello and welcome to another day of calculus. Day, minute, I don't know, whenever you're doing this. This is the first one for me today of making these videos. So we're going to jump right into this. This lesson makes me excited, but also nervous in some ways. In the past, this has been a lesson where the trickier limits, I knew there was only 1 or 2 questions on the AP exam, and so I just kind of skirted by them and I didn't jump into these ones too much, but I think that you are smart and I think that you can do it. And so we're in this together and we're going to work through this. If you don't understand this right away, know that you are not alone and that these ones are hard, but you're smart and I'm confident in you and you can ask as many questions as you want. So please do. Okay, let's do this thing. So the first thing I want to talk about is it says the commonly memorized limit composition rule is generally presented something like this. So it says if the limit is x approaches a of f of g of x, so that's what we're talking about, composition of functions. There's a function within a function. Equals, what you do is you take the limit of the inside function and then whatever value you get, you just substitute in and find the function value for the outside function. So, and it says provided that the limit as x approaches a of g of x is equal to L and f of x is continuous. So let me show you what I mean by that before I read through all the rest of these. If you look down at part A, in this one, it says find the limit as x approaches 1 of f of g of x. So I know this one's kind of hard to see, but I'm actually going to do it over here. And I'm going to write it a couple different places on here. I'll change colors just so you can see this a little bit better. There's not a ton of room to write, so I apologize. What I'm going to do for the limit as x approaches 1, it says of f of g of x. I'm actually just going to focus on this g of x first. And this is where it's really important to label that this graph is f of x and this is g of x. So what I'm going to do is take a moment and look, what is the limit as x approaches 1 of g of x? So g of x is this function. Okay, so if we said the limit is x approaches 1, you can see from the left, from the right, I'm going towards 0. So you get 0. And then what you have to do, because of this f of g of x, and I can see that the function value at 0, there's a point there, but do you see how the function is continuous? I never pick up my pen. Well, right now I'm totally picking it up because I'm not even putting it on the paper, but you know, I could just draw on this the entire way. So I'm going to say f of 0 and I get 2. Therefore, the limit as x approaches 1 of f of g of x is 2. And that's it. So if you have a function that you have a limit and you've got a function within a function, a composite function, you take the limit of the inside, and then whatever the limit is, you say, well, I'm just going to find f of that value. So whatever the outside function is, the function value at the point. That's only if this function f of x is continuous. There are other problems, and this is why these are non-traditional limits, operations on limits. These are kind of trickier because you might have something else that you need to do. So let me get another color. Orange, that's the next one. Well, that might be hard to see. Hold on. Brown. Let's do that. Okay, so in part B, the question is the limit as x approaches 2 of f of x times g of x. So what I would first want to try to do, and what we've done the entire time up to this point, we would have said that the limit as x approaches 2 of f of x, where is it? X approaches 2, this doesn't exist. And then so I wouldn't even worry about times g of x. But we have to consider that if the left-hand limit equals the right-hand limit, then the limit exists. So what I need to do is I need to break this up into the left and right-hand limits. And that's what this entire part is talking about here. That if we do not have a traditional limit working for us for some reason, if we do not, oh, sorry, it went off the screen. There we go, I'm back. If we do not have, if we see that the limit does not exist in some part, so like in this one, the limit as x approaches 2 of f of x, the left doesn't equal the right. I can't automatically say that this limit does not exist. I need to dig a little deeper. So I'm going to do that. I'm going to find out what is the limit as x approaches 2 from the left? Still do f of x times g of x. And I want to see, does it equal, this is an equal sign with a question mark on top of it, the limit as x approaches 2 from the right of f of x times g of x. So now I'm going to look in and I'm going to say the limit as x approaches 2 from the left. Here's f of x. 2 from the left would be 0. G of x, what is the limit as x approaches 2 from the left of g of x? This is where you're supposed to do it. If I'm going to 2 from the left of g of x, I would say that's probably like, it's really hard to see on here because the copy is bad, but 1. And then I'm going to see, is that equal to the limit as x approaches 2 from the right of f of x times g of x? 2 from the right would be 1. 2 from the right of g of x would be 1. And so I know this is a lot of work to say the thing that we thought was true in the first place, but in this case, 0 does not equal 1. That means these limits are not equal, the left and the right. And now we can say that this limit does not exist. I know that's a lot of work to get there, but you're just being a little bit more exact, and there are certain times, I guess I should say, you're being more precise about why a limit doesn't exist, and you're checking all roots. So just because one of your limits for f of x times g of x doesn't exist, that's not enough right away. Because if you dig a little deeper, if you do the left-hand limit and try to set it equal to the right-hand limit, it might not exist still, like this one, but it could. Okay, so we did this one, we said this does not exist. The first one, by the way, we said was 2. Okay, so far, not so bad. So I wouldn't say exactly they're easy peasy lemon squeezy, but this one I might consider difficult, difficult, lemon difficult. That's the less common phrase, but maybe you've heard it before. Maybe only if I've said it, but whatever. Okay, so a slightly different blue. We're going to go to C. This says the limit as x approaches 0 of f of x. So it's still a function. There's f of x within here. So let me try what we did before. I'll go down here. C. Okay, the limit as x approaches 0. And then I'm going to put in f of x, because that was the inside function. Limit as x approaches 0 of f of x. So if I'm approaching 0 of f of x from the left, from the right, I'm going to 2. And this is the craziest part of all of this. What you need to consider then is, how am I getting to 2? Like, if this is limit as x approaches 0 of f of x is equal to 2. Oh wait, I should try the next thing, sorry. I'm going back a step. If this is the limit as x approaches 0, f of x is 2. But I go over here to 2, and I can see that there is a split, like there's a jump discontinuity. I can't automatically say that the limit does not exist. In fact, this one, it will exist. I need to do a little bit more work. And this is the part, I hate to admit this, but I have, and I'm thinking that you might be able to relate, which is why I'm just being vulnerable. I just avoided this problem for years because I didn't understand this part, but now I do. So if there's parts on this that you don't understand or I'm not being clear on, call me on it, ask me it, and we will talk about it. I will figure out different ways for this to make it work for you. Okay, so limit as x approaches 0 of f of x is 2. I can't just substitute in f of 2 to find my answer. So what I need to look into is I have to examine this 2 a little bit more. Limit as x approaches 0 of f of x isn't just 2, because I'm going to use this in a second and say the limit as x approaches 2 of my outside function f of x. So I'm changing this 0 into a 2. But here, do you see how I'm going up from like below on both of these? And right now you can be like, it doesn't really matter because these are y values. And so you're like, why does above or below matter? What matters is I'm suddenly changing this from a y value to now it's going to be an x value down here. X is going to be approaching. So it matters to me whether I'm approaching from above or below, because that will help me determine left or right for my value of x. So if I got 2, but I can see I'm coming from below on both sides, this is actually just 2 from the left. So down here, when I figure out my final answer, my limit as x approaches 2 from the left, because I'm doing this outside function, this f of x here. And I'm saying 2 from the left of f of x, 2 from the left would be 0. So this whole limit is 0, even though it seems like it would be does not exist at first. So I know this is the crazy one. This is by far the hardest one, but we're gonna work through this together. We can do it. We got it. I believe in us. Okay, let's do another one. These are a little tricky too. So in this one, for the limit as x approaches -1 of f of x plus g of x. So let's just go see if we can do this the regular way first. Meaning, the limit as x approaches -1 of f of x. Oh man, do you see how there's like a jump here? So that's not going to be cool. I don't like that already. And if I do g of x, limit as x approaches -1 of g of x, ugh, not cool. But now we need to consider the left and the right. So I'm going to go back to blue again. So I'm going to say, well, what is the limit as x approaches -1 from the left of f of x plus g of x? And is that equal to the limit as x approaches -1 from the right? I know this is hard to see. I'm trying to squeeze this in. F of x plus g of x. So if I do that, if I'm looking only to the left of f of x and g of x, what I want you to do is figure out right now, what is the limit that x approaches -1 from the left for f of x? This is f. -1 from the left would be -1. What is the limit as x approaches -1 from the left of g of x? G of x is right here. From the left would be -2. And I want to see, is this equal to the limit as x approaches -1 from the right of f of x plus g of x? So from the right, the limit as x approaches -1 from the right is -2. Well, that's a good start. And is it equal to the limit as x approaches -1 from the right of g of x? -1 from the right of g of x, -1. What? -1 plus -2 is -3, which is equal to -3. My limit, because all that has to be true for a limit to exist is the left has to equal the right, is -3. Okay. That's a lot. If you need to take a minute, make this sink in, or try the next one on your own. Well, the next one's kind of hard to try on your own, but if you need time to have this sink in, that is okay. Also, if we're talking about this, I guess I should have set up here too. This was the left and the right. Sorry, I didn't include that before. It's that same idea that the left-hand limit has to equal the right-hand limit. Like, we're still using those same basic ideas, but this is the trickiest that these limits will definitely get. Okay, let's do another. This one's fine. The limit is x approaches -1, f of x plus g of x plus 1. Okay, that's gross. So what I want to do is I want to say, what is the limit as x approaches -1? Or I'm sorry, is it 1 or -1? Oh, approaches 1. 1 from the left. That's definitely gonna, I'm just gonna cross all that out. Okay, the limit as x approaches 1 from the left of f of x plus g of x plus 1. And I want to see, is that equal? I'm not sure yet. To the limit as x approaches 1 from the right of f of x plus g of x plus 1. Okay, so I'm saying, is this true? Is the left equal to the right? Okay, so we start off and we say the limit as x approaches 1 from the left of f of x. 1 from the left of f of x. So look at that. 1 from the left. I don't care what's happening at 1. What I care is that it's approaching, so I would get a value of 2. Plus, the limit as x approaches 1 from the left. So let's think about this. 1 from the left would be something like 0.9, so a little bit less than 1 plus 1. So I'm thinking, what is the limit as x is approaching 2, because 1 plus 1 is 2, but I'm still going from the left here, because 0.9 plus 1 would be like 1.9. So I'm still thinking about from the left. So if I go over to g, I'm still saying from the left, but now this time I'm going to 2, because 1 plus 1 is 2. So from the left, and I get 2. And then I'm saying, okay, well, is this equal to, on the other side, the limit as x approaches 1 from the right of f of x. So 1 from the right of f of x would be 2. G of 1 from the right, so 1 plus 1 would be 2, but it's a little bit to the right, so 2.1. I'm going to the right, would be this value of 3, I'm guessing. These limits do not exist because 4 does not equal 5. The left doesn't equal the right. So this limit does not exist. I know this stuff is difficult, but I also know that you're really smart or you wouldn't be in this class. So we got this, and I got you. Okay, next page. We're going to try this. And the nice thing about this, there's 8 questions on here, but what you really need to know is that this is the graph of f of x. If you need to write that really big, do so. This is the graph of g of x, and you're going to be using each one of these. Okay, so the first thing I want you to do is just try to find this value, f of g of 4. And go. Okay, g of 4 you find first. So you go to the graph, g of 4, you get a value of 6. And then I find f of 6. So f of 6, the function value at 6 is, hold on, I'm making sure that I've got this. I've got f of, I'm going to make sure because the answer key looks different here. G of 4 was 6. F of 6, oh, there it is. Okay, I almost said that it was 1. It's not because there's a open hole here. There's the same thing here. Here's a hole. This function value, not the limit, just the function value, would be at 4. Ta-da! Okay, so we got 1. Let's keep going. The limit as x approaches 4 of f of g of x. So what I'm going to do first is I'm going to see the limit as x approaches 4 of just the inside function. So see if you can find it. The limit as x approaches 4 of just g of x. G of x. The left and the right are both the same. I got 6 for that part. And then what I want to do next is I want to see if this is continuous. I would say f of 6 and I would get 4. Oh no, it's not continuous. So what I need to do is I want to think about, okay, when I got 6 here, the limit as x approaches 4 of g of x, was this just 6 or was it below or above? So like where were those values approaching? So if I look here, do you see how these y values are increasing? Y values are increasing. So this is like coming from below. And normally that wouldn't matter from a limit, but because this is a y value right now coming from below, but in a second I'm going to change this to limit as x approaches 6, so an x value, that's the same as left. So from below, be left, of f of x. Now all I'm looking for is the left-hand limit. The limit as x approaches 6 from the left of f of x. Limit as x approaches 6 from the left of f of x is 1. This problem is so tricky. If you got it already, amazing. If you didn't get it yet, let's chat. Or keep trying the other ones. Okay, Ooh, it got quieter. My washer just shut off. Maybe I shouldn't make videos when it's on, but you know, gotta do what I gotta do. My son's sleeping, so I do it when he's taking a nap. Okay, next one, f of g of 0. This is nice. It's a little reprieve. This is just asking me to find the function value. What is g of 0? G of 0 is -2. F of -2, the function value at -2 is 1. It's just where is it a filled in dot. Oh, sorry, you can see that very well. F of -2 is 1. That's it. Okay, so we got this one. Feeling good. Moving on to 4. We're almost halfway there. Limit as x approaches 0 of g of x. So we always start on the inside. So limit as x approaches 0 of g of x. X approaches 0 of g of x. This is g of x. And I see that I'm getting a -2. So the next thing I do is if at f of -2, this function is continuous, I wouldn't have to do anything else. But sad for us, it's not. So what I need to do is think about, okay, was this coming from above or below? So that when I write the limit as x approaches -2 of f of x, I know whether to look at the left or the right. Okay, so for this one, limit as x approaches 0 of g of x, all of these values are coming from above. They're starting bigger, and as I get closer and closer to 0, that's when I get to -2. So the same thing if I'm coming from here, from the right, I can see these values, these y values are getting bigger, and then smaller here. So I'm coming from above. So if I look at, and I'm just checking myself, yeah, I'm good. Because this is from above, the y values are getting bigger and going smaller. That's what happens when I come from the right for an x value. Now I can go to the limit as x approaches -2 of f of x, and I'm looking from the right. So -2 is right here, right here. I'm going from the right, and I get a value of 3. Whoop, whoop. We did it. Sorry, it was behind my face. Okay. Whoa, halfway there, whoa. Did you sing it? Did you sing the rest? Okay, keep going. This is so weird not being in a classroom, but we're gonna do what we have to do to make this awesome. Okay, limit as x approaches 6 from the left of g of 1 minus f of x. Okay, we got this. So in this one, we have to focus on this part first. So 6 from the left. The limit is x approaches 6 from the left of f of x. 6 from the left of f of x would be, coming right here, we would get a value of 1. So, this would be limit as x approaches 1. And do you see how I'm coming at it if it's from the left, how I'm going from above? Do you see that? It's kind of hard because I'm going, my y values are coming, they're more and more positive and then getting closer and closer this way, but I'm going like to this value from a higher y value to a smaller y value. So that's why it matters when I change this into limit as x approaches 1 from the right. And now this would be g of 1 minus x. Okay, get ready. This is another strange moment, but if this is the limit as x approaches 1 of g of 1 minus x, 1 from the right, think about a value slightly to the right of 1. 1.1, 1.01. Now let's think 1 minus 1.1. 1 minus 1.1 would be negative 0.1, right? So this would really be thinking about 1 minus 1.1 would be the limit as x approaches 1 minus 1.1 would be 0, but then a little bit to the left. Does that make sense? 1 minus 1 is 0. 1 minus a little bit more than 1 would be a little less than 0. So 0 to the left of g of x. I realize this one is tricky, so please, please, please let me know if you don't understand this. limit as x approaches 0 from the left of g of x, 0 from the left, would be -2. Whew. If your brain isn't sweating right now, I don't know. In this one, it actually wouldn't matter that much if you mess this one up and you're like, why does it matter if 0 from the left or the right would be -2? You do you. You're right. I just want to tell you in case it wasn't that way. Okay, let's do another one. Limit as x approaches 3 from the right. So we're worrying about like the function within a function first. Limit as x approaches 3 from the right. And I'm going to write this as, this would be 3 from the right. I don't know why I'm rewriting this, but I am. 15 minus x squared. Okay, what we need to work and focus on is the limit as x approaches 3 from the right of x squared. And see what we get for that. Okay, x squared is a parabola. Looks like this. 3, if it was over here somewhere, it'd be like that point. 3 from the right would be this way. Like I'm coming in from the right. 3 squared is 9, so I get a value of 9. But do you see how I'm coming from above and getting closer and closer? So that would be 9 from above, or 9 to the right. The reason why that's important is because now I'm going to say limit as x approaches 9 from the right of f of 15 minus x. If I put in limit as x approaches 9 from the right, I would get, I don't even want to do this. I can do some things with u's and v's, but I think it makes it more confusing. So some of this you almost have to do in your head if you do it this way. But I could do 15 minus 9, which would be f of 6. If I go up here and I'm like, oh crap, it's not continuous there, so I need to do more work. 15 minus 9 from the right would be, I would need to be thinking about 15 minus a little bit more than 9, like 9.1. 15 minus 9 is 6, but 15 minus a little bit more than 9, 9.1, it's going to be 5.9, which would be the limit as x approaches 6 from the left of just f of x. I know that's so much work on that one, but I also know that you're smart. Okay, so 6 from the left of f of x is 1. You're doing great. Okay, so moving right along. And number 7, and I realize this is getting kind of yucky, but we're going to keep going. I'm worrying about this x squared first. So the limit as x approaches 2 from the left of x squared. X squared looks something like that. And I'm not even worrying about the minus yet. This says 2 from the left. I didn't include the minus here. Of the x squared. And I'm going to approach 2. So kind of similar to the last one. 2 squared is 4. We always try to substitute first for limits. But if I'm going from the left, I'm coming from a value below it. So I'm going to say 4. But this value is coming below 4. So I'm going to say 4 to the left. Now I can say the limit as x approaches 4 from the left of g of 2 minus x. Because I no longer have this as just an x squared. This would be, if I did 2 minus 4, I would get -2. But remember, this is from the left. So this is really like 2 minus 3.9, which is hard to do in my head. Wait, 4 from the left, yeah. 2 minus 3.9 would be, 2 minus 2 is 0, 3.9, hold on. 2 minus 4 would be -2. 2 minus 3.9 would be -1.9-ish. So that'd be limit as x approaches -2. Remember, this is weird because it's negative isn't positive, but -1.9 would actually be from the right of g of x. Limit as x approaches -2 from the right of g of x. So for g of x, -2 from the right, we would get 0. If you were crying because of this, stop now. So, honest truth, I'm an AP Calculus teacher. I've been doing this. This is, I don't even know what year this is. This is my 14th year teaching, but I think it's like my 6th or 7th year teaching AP Calculus. My students have done very well in the AP exam. People have known this for a long time. I think I'm pretty good at my job. I like my job. I want to do it well. This is not an area I've focused on for years. People still have gotten lots and lots of 5s and done very well and understood calculus. This is just like nitpicky, and I want you to have the best chance just to understand everything that you possibly can, because it's awesome. So anything that you need help with, please ask me, but also no crying over this. It's okay. Okay, let's do one more. Actually, you try this one too, and then come back to me in a second when you think you have an answer. You can pause the video. I'm going to keep going. Limit as x approaches -2 from the left, and I'm going to start with this inside function of f of x. -2 from the left. F of x would be -2. I'm going to say the limit as x approaches -2. Oh wait, and I should have done f of x -2 from the left. This was coming from above, because it was from above. So then when I switch it, I'm going to say limit as x approaches -2 from the right of f of x. From the right of f of x is 3. Okay, that was a whole lot of work, but you did it, and you're smart, and I believe in you. And if you are sad right now, don't be. One, it's just math. We can figure this out together. Math is very important, but you're more important. So please let me know how I can help you and how I can, just support you in this. You got this. I believe in you. And, my shirt says, let's root for each other. And I'm definitely rooting for you. Okay, till later. Bye.